Guys, it is your favorite teacher, Mr. Peters here, talking to you from Lesson 88 today. We're going to be talking about quadratic equations, as well as the solution of quadratic equations by factoring. How to find solutions of quadratic equations by factoring. So we have dealt with factoring quite a bit already, and if you guys remember, factoring is just whenever we take a trinomial and we kind of undo the distributive property and break it apart into the product of two binomials. Okay, so we will be applying that to quadratic equations, not just expressions. So before we get started, let's talk about some vocabulary. So when we say quadratic, what that refers to is second degree. That is saying that the highest power within our equation is of second degree. So if you look right under where I have second degree written, see, that's this term right here. That term, the highest power within our quadratic equation, is of second degree. So it's not a quadratic if it's got x cubed or x to the fourth, right? Those are not quadratic equations. We are only going to be factoring quadratic equations, okay? Your next term, standard form. Standard form is whenever you write out your quadratic equation in the form ax squared plus bx plus c being equal to 0. Okay, that is what standard form looks like. Now, a, b, c, those are not going to be the values that you actually see. A represents some number, B represents some number, C represents another number. You're not going to see extra A's, B's, and C's in your quadratic equations. Finally, roots. Roots are what you find whenever we perform factoring to solve a quadratic equation. We find the roots. And roots are also just solutions. So whenever we factor and find the roots, we've also found the solutions. We've done more than just find solutions, though. We've also found the x-intercept, where the graph of this quadratic equation crosses your x-intercept. These are often referred to as zeros. So all of these guys right here, they're the same thing. They're interchangeable, and you may see it say roots one time, and then it might say find the zeros next, or find the solutions of. You don't need to worry. They are all referring to the same thing. And what you guys don't know quite yet, but what you will know, is whenever you graph a quadratic equation, what you get is a nice little U-shaped graph. You get something that looks like this. Right? And these points where it crosses the x-intercept, those are the roots of this equation, or the solution of this equation, or the x-intercepts, right? That's where it crosses the x-intercept. Also called the zeros because they are where y equals 0. All right, so you don't need to worry about this right now. We'll get to that later, but that just should kind of give you a visual representation of what it is that we are going to be doing. Okay, so the zero factor theorem is a theorem that you guys aren't going to need to be able to repeat word for word or anything like that, but it just kind of gives you the idea behind why we're able to do what we do, right? And this reads, if you've got two things that are multiplying together to give you 0, right? In this case, we've got A times B, and they equal 0. Well, how do we get A times B to equal 0? Well, one of them has to be equal to 0. Either A is equal to 0 or B is equal to 0, right? There's no other way for this to work unless either A is 0 or B is 0. All right, so we are actually going to be applying the zero factor theorem to factoring, right? And so let's look at our first example problem. We've got x squared minus 18 is equal to 3x. Your first step in solving one of these equations, one of these quadratic equations, is going to be to move every term over to one side of your equation such that your equation is equal to 0. And we want to make sure that we put it in order, right? So what we're going to do is we're going to move 3x, we're going to move 3x over to the left side of this equation, right? What this does is 3x minus 3x gives me 0. And what do I have on the left side? I now have x squared minus 3x minus 18. That's equal to 0. This right here is written in standard form. That's what we want. We want to get it in standard form. And let's switch up our colors for the next step, okay? Now what we have is we have our quadratic equation, right? Ax squared plus bx plus c equals 0. That's standard form. But what we need to do now is we need to factor this. Now, normally, what you guys would have is you would have just the x squared minus 3x minus 18. You would just have this expression. But we've included this equals 0 now because it's an equation and we want to solve for what x can actually equal. So let's go ahead and set up our parentheses for this binomial, or for these two binomials, sorry. Okay, well, I've got minus, and I've got another minus, so I know I'm going to have an x and an x. Well, since they multiply together to give me negative, and then add together to give me negative, I know I'm going to be going minus plus, right? I need to have a negative times a positive to give me a negative, and I need to have my negative value be larger than the positive value so that when they add together, I'm left with a negative middle term. Okay, so the two values that I could multiply together to give me negative 18, that add together to give me negative 3, well, that's going to be negative 6 and positive 3. Right, so first step, or well, I guess second step really, is done. Right, we finished it. We found that x minus 6 times x plus 3 is equal to 0. But what does that really do for us, right? We still don't know what x equals. This is when your zero factor theorem comes in handy, okay? Because we know that a times b, if a times b is equal to 0, and in this case, that's what we have. Look, I've got a, I'm going to let this right here be a, and I'm going to let this right here be b. If a times b is equal to 0, then either a is equal to 0, or x plus 3, b, is equal to 0, right? Look, we've got these two different binomials, and we know that one of them has to be equal to 0. So by taking this and splitting it up like that, we can now solve for our two possible values of x, right? So over here, what I can do is I can add 6 to both sides of my equation. They cancel here, and I'm left with x equals 6. Over here, I can subtract 3 from both sides of my equation, and I get x equals negative 3. Those are your zeros, your roots, your solutions, right? The x-intercepts, all those things that we were talking about earlier. So we can write this as x equals 6 or negative 3, right? That's our answer. We're done. We have found the solutions to this quadratic equation. Now let's go through one more example together that maybe is going to look a little bit different, and then I'll let you guys get started on your homework. Okay, so the next example I want to look through with you guys is negative 25 is equal to negative 4x squared, right? And what I want from you guys is, and I'm going to actually write this a little further down. We're going to be finding the roots of, find the roots of negative 25 is equal to negative 4x squared. Some of you may be thinking, wait, but Mr. Peters, this is not a quadratic because it's not in standard form. I only see two terms. How am I supposed to solve for this? Well, your first step is going to be to get every term onto one side of your equation such that it is equal to 0. So what we're going to do is we're going to add 4x squared to both sides of our equation. Negative 4x squared plus 4x squared, well, that just equals 0. And on that left side, I now have 4x squared, right? I always want to have my highest degree on the left, minus 25 equals 0. Now, even though it doesn't look it, let's go green here. This is in standard form. This is in standard form. You may think, but I don't see the b term, right? I see ax squared and I see c, but there's no bx. Well, there is. It's just that b in this instance is equal to 0, and that's all right. We can have a binomial that is still a quadratic equation, right? It's still quadratic because look, squared. It's the highest degree that we're dealing with. Okay, so how do I factor this? Maybe you remember, maybe you don't, but this is what we call the difference, right? Difference because we are subtracting the difference of two squares. And when you have the difference of two squares, it's so easy, so simple to factor, right? We take the square root of our first term, that's 2x, and we write that in the first spot holder. Then we take the square root of the second term, 25. Well, square root of 25 is 5. And since we've got a negative, we need to make sure that our 5 times 5, we've got one that's positive, one that is negative. So we have 2x plus 5 times 2x minus 5 is equal to 0. Remembering to set this equal to 0 is very important because if we don't have this, right, and what we're left with is just 2x plus 5, 2x minus 5, that product there, where can we go? We can't solve for x. So we have to make sure that this is equal to 0, because when it's equal to 0, we can actually solve. We can actually find what x equals. So, utilizing our zero factor theorem, we can state, well, this means, and let's switch up our colors again, that 2x plus 5 equals 0, or 2x minus 5 equals 0. Right? We are able to take our two binomials and say, well, one of these has to be equal to 0. It's possible that both could be equal to 0. But let's solve for x to find our roots, to find our solutions, to find our zeros, to find our x-intercepts. All right, so over here, we get to subtract 5 from both sides. Oops, let's get rid of that. Subtract 5 from both sides. We're going to cancel and get 2x equals negative 5. Divide both sides by 2, and we now have x equals negative 5 over 2. Or we could add 5 to both sides on this right side and get 2x equaling 5, or x equals positive 5 over 2. When you are dealing with the difference of two squares, your answers will always be opposites of each other. All right, so I can bring these two guys together and say, well, this means that x equals plus or minus 5 over 2.